you'll have you recognize this, but then there's also a fraction that's to the power of 2. So now many students think that we should expand like x minus 3, x minus 3 squared. You think we should expand it, but actually that will just make your life a lot harder. The best way to do this is this method that I'm going to cover in this video. So let's take this as an example of a chair. Let's add 2 by 3 plus 3 by 4 plus 3 by 4 squared. So how do we find the LCM over here? So in normal ways that we've learned since like fourth, fifth grade is how we would, like manually think of a number which belongs to the 16 times table because 4 squared is 16, the 4 times table and 3 times table. So let's think 3, you should get LCM should be 48. But the best way to solve the LCM, the best way to find the LCM over here is to multiply the first unit. You can see that 4 and 4, these are common bases, right? So let's take different bases. So we have two different bases here. We have base 3 and we have base 4. And base 4 has to the power 1 and to the power of 2, right? So we multiply the two different bases. We multiply the highest power of the two bases to find the LCM. So the highest power of 3 over here is 1. What the? The highest power of 3 here is 1. So we multiply 3 to the power of 1 with the highest power of 4 over here is 4 squared. So we multiply 3 to the power of 1 with 4 squared. So 3 into 16, put that on your calculator and you'll still get 48. So that's a method of finding the LCM. Multiplying the unique bases, right? The highest number, the highest powers of the unique bases with each other to find the LCM. So we're going to be applying the same thing over here. Let me just erase this and show you. So similarly, actually I'll keep this over here. So similarly as to how we found the LCM over here, we apply the same strategy over here. So remember how in partial fractions you always do a plus b. Okay, look at the highest power of 3. Look at the highest power of x over here. So the highest power of x, I'm going to, let's just think mentally. Let's expand. When we expand this, you should get x squared dot dot dot, and you multiply this with x minus 2. So the total power of x in the denominator, when you multiply this over here, it will be x to the power cube. X to the power 3. Well, yeah. So this power will tell you how many partial fractions you will have to make. So this power is to the power of 3. So that means we'll have to make 3 partial fractions. So plus c. And we take one factor over here. And look at how I did this. Unique number 1, unique base number 1, and unique base number 2. Unique base number 2 ka power 1, then power 2. So I do b to the power x minus 3. And then over here I do x minus 3 squared. So when we do calculate the LCM, we only multiply these two numbers together, similarly as to how we did multiply these two numbers together. And look over here, that's exactly what's happening here. You're multiplying x minus 2 with x minus 3 squared. I'll remove all these arrows. X minus 3 squared. Right. So let's actually solve this so you can find values of a, b, and c. Similarly as to how we did case 1, you just move this entire denominator to the right side of the equation. Now you should get a x minus 2, x minus 3 squared over x minus 2 plus b x minus 2, x minus 3 over x minus 3 plus c. I'm running out of space over here. I'll move it down over here. I'll try fitting it. X minus 2, x minus 3. I don't know if you can see this. Squared, x minus 3 squared. Yeah, I completely ran out of space. But I think you should be able to fill in the blanks here. I think after watching my previous video, you should be able to predict what I write. So you can see x minus 2 and x minus 2 is common, so we cancel that. X minus 3 squared and x minus 3. So one power is cut over here, this entire fraction. And how about I just write this over here. C is x minus 2. These two are common, so we cut those as well. Let's write our simplified equation. X minus 3 squared plus b x minus 2 x minus 3 plus c x minus 2. Okay, so same procedures we did before. You take each of these brackets and you equate them to 0. So x minus 3 equal to 0, x is equal to 3. That's our first value of x. So 3 plus 3 is equal to a 0 plus b. So you can see x minus 3 over here is going to be 0, so I don't need to calculate this. I can just straight away write 0 in its place. And over here, c, either different oka, so 3 minus 2. So 36 plus 3 is equal to c, 39 is equal to c. Now let's find the value of a. Let's equate x minus 2 to 0. And so x is equal to 2. 12, 2 plus 3 is equal to a. 2 minus 3 squared plus b. You can see x minus 2 over here is going to be 0, so there's no need to write it. And c as well, this is going to be 0, though there's no need to calculate. A little tip I should tell you guys is that in these types of questions, when you find one value of x, usually you will only get like a value of a, and all other values are 0. As you've noticed, right, this is becoming a pattern. When I found 3, I got this as 0, and I got this as 0, but I got this as a number. So when you identify that number, there's no need to even look up. You can just already tell, okay, all the rest of the other values will be 0. Right. So 24 plus 3 equals to a, because negative 1 squared is 1. So a 27 equals to a. So far we've only found the values of a and c. How do we find the value of b? So you can see when I put x is equal to 3, right, I got b as 0. And when I put x is equal to 2, I got b as 0. There's no other value of x I can put in to find the value of b. So there's another method here you would use to find b. And this is... Okay, so we found the value of a, so I want to replace it over here. X minus 3 squared plus b. X minus 2, x minus 3 plus c, x minus 2. Right. So I want to... Let's just expand this and let's expand this together. So 12x plus 3 is equal to 27. X squared minus 6x plus 9. You should be able to do this mentally. With a squared minus 2ab plus b squared. Plus b. Now let's do this. X squared. Sorry. No, this. So x squared minus 3x minus 2x plus 6. I'm not using a calculator, so excuse any calculation errors, but I think you should still be able to get the concept. X squared minus 6x plus 9 plus b, x squared minus 4x plus 6 plus c, x minus 2. Oof. All right. So, as we have already told in the previous video, whatever is written over here is going to be equal to whatever is written over here. That means the coefficients are going to be the same on both sides of the equation. So let's take the easiest example here, which is the coefficient of x squared. You can see on the left-hand side of the equation, the coefficient of x squared, you don't see any x squared, right? You just see 12x plus 3. So you can say that this is equal to 0x squared, right? We can say that the coefficient of x squared is 0. You can say the coefficient of x cubed is 0. It just goes on and on. That's because there isn't any x squared term on the left-hand side of the equation. So we're going to have to, say that the coefficient of x squared on the left hand side of the equation is 0 because you don't see any x squared. But over here, there are two values that should have x squared in them, which is 27x squared and bx squared. So coefficient of x squared equals to 0. So we can see 27x, 27. So the coefficient of x squared over here is going to be 27x squared plus bx squared. So 27 plus b is equal to 0. I hope you understand what I've done here. So 27, so b is equal to negative 27. So I think you should understand what I've done here. I just expanded this, and I basically tried finding similarities between the two equations that are shown on the left hand, right hand side of the equation, and I just compared the coefficients of terms here. So there's no term that has x squared on the left hand side of the equation, so I'm going to assume that the coefficient of x squared on the left hand side of the equation is 0. So since whatever I write over here is going to be equal to whatever I write over here, if the coefficient of x squared over here is 0, that means that the coefficient of x squared over here is going to also be 0. And all the terms that add up to x squared are this term and this term. So I can, logically assume that 27 plus b should be equivalent to 0. And that's how I found the value of b as well. So let's rewrite our equation. That's case 2 completed. So let's 12x x minus 3 squared. Okay. What's the value of a again? The value of a was 27, right? It's always mandatory to write your answer at the end like this. Minus 27 x minus 3 plus the value c that we found was 39 plus 39 over x minus 3 squared. That's our final answer. So that's case 2 covered. Share with your friends if they need any help with this chapter. And just go through the entire lecture, try absorbing what I did here.